up. Today we're going to be finishing up section 15.5.
Copy stuff from like our note cards onto this, right?
Yeah, you can put stuff in the packet if it's like how to do problems or whatever, like that is okay. Or if it's like facts that are relevant to doing the problem. Yeah, it can be very process driven inside of your packet. As long as it's like relevant to that problem that you're working on, it is okay to put other stuff in there that's like, this is how I knew to do this, and like this is what this means, and like I needed to use this formula or whatever. That is all okay. All right. So today last time we'd been talking about, we talked about simple and compound interest, right? Today we're going to start by talking about continuously compounding interest, and then talking about an APY and annuities, and then we'll show you some calculator stuff, and it's donezo for today. Yes. Yes. Yeah, we're going to do the chapter 15 test next week. And then we're doing one more set of topics, and we'll see whether, depending on when we finish that up, whether we'll do another test on that or if it'll just be part of the final exam. So that's a little bit TBA, but one more for sure. All right, so first up, we're going to talk about continuously compounding interest. When I say continuously compounding, how many compounds per year are we talking about? Like, what is continuously going to be meaning? So, like, what number or number-ish? Infinity, yeah, there's infinitely many compounds per year. Essentially every instant a compound is happening. So we're going to take our compound interest formula, and if that value for K goes to infinity, what it does is it turns into this. Where F, V, P, V, N are all the same. This letter E, though, remember, that's like that irrational number that we've talked about earlier. Surprisingly, that's what kind of tumbles out. In particular, when you talk about things going on in like the real world, oftentimes exponential change in the real world is constantly occurring. If you think about a very large population, constantly, people are being born or dying. So like this constant or continuously compounding often has a lot of application into like the real world. Or if you have like an electrical discharge that's happening, like that's kind of, continuously going on. So like that value for E pops up surprisingly a lot in real world application. But that's essentially just our new formula, that when K goes to infinity, that part of the function just turns into E. I'm going to not belabor the details there because it's a little bit beyond the scope of this class, but that's what's going on. All right, so let's do an example here. It says that Gwen has $600 to place into a savings account. What annual Oh my goodness. I'm in the wrong spot. This is not what I meant to put in. We did this problem already. Bloop. That's the one I want. Okay. My apologies. That's better. Jack invests $800 into a savings account with 5% annual interest compounded continuously. So as soon as I see that, I know I'm going to be using that continuously compounding interest formula. How long will it take for Jack to have $500 in interest? So how long is it talking about the value for N? I see I have a PV, I have an R, but $500 in interest is not a future value though, right? But we can make it one. So remember that the future value is just the present value plus what we've earned in interest. So my future value would be 1,300 in this case. The 800 we started with plus the 500 in interest that we've earned. So now that I have all this, I can just plug in. Where's the variable located in this problem? It's in the exponent. What am I going to need to do to solve for that then? If the variable's in the exponent, I need to use a logarithm. Before I can use that log, though, I have to get that exponential part by itself. So let's divide by 800 to do that. Oops. I'm going to reduce that fraction because it's easy to do right in our heads. Now, which logarithm base do I want to choose to use here if my exponential is e to the 5n over 100? Great. I want to use log base e so it matches the base of the exponential. Log base e has a special name, that's the natural log, and a special symbol, which is ln. So I'm going to do the natural log of both sides. And pew pew. And then my last step would just to be multiplied by the reciprocal. So multiply by 100 over 5. And we should be all good to go. So I get about 9.71 years. Absolutely. All right. So any questions on this? Pretty easy, right? Just like another formula. Fairly easy to read the story problem and know that when to use it. What word are you looking for this formula? Continuously. It'll say it in there if it's time to use it. The next thing we want to talk about is something that we'll all probably have to do in our lifetime, which is going to be shop for loans or like select an investment. So how, like at first glance, it's really difficult to tell like which would be the better option. Like this interest rate compounded this many times, or this other interest rate compounded a different number of times. Like that's not obvious which one would be the better option for us, and something that's potentially like thousands of dollars, or more, like really important that we make a good choice here. So one way that we can kind of tell the difference is using something called an APY, which stands for like annual percentage yield. And it's basically the equivalent interest rate if K is equal to 1. So basically it just takes, I have this interest rate compounded this many times a year. What is the equivalent interest rate if it was compounded once per year, just annually? That's what an APY is. So oftentimes if you're shopping for a car loan or a house loan or whatever, they're going to report the loan interest rates as APYs. That's what APY means. The actual terms of your loan may not be compounding annually, but I think it's a consumer law in America that they have to report all these loan offers as APYs, so that it's not like impossible for a doofus to make a good choice as to what they want. So the formula, the trick to do this, to calculating an APY, is as follows. So that's our formula, 100 times the quantity, 1 plus R over 100K to the K minus 1. R and K are still the same, usual. R is your interest rate. K is your number of compounds per year. That's going to convert that interest rate into the interest rate for 1 compound per year. So if you have a situation where you're offered 2 different options, you can convert them both to APYs and make a choice based on that. So here we're asked which savings account would be the better investment. One that pays 7.8% interest compounded quarterly, or one that pays 6 or 7.65 compounded weekly. So all we're going to do is calculate an APY for each of these and then compare. And what are we looking for if this is an investment? Do we want the bigger or the smaller APY? What do you guys think? If it's an investment, bigger or smaller? Use that common sense. You want the bigger one for an investment. If it's a loan, you want the smaller. So if it's going to mean the money you have to pay back, you want that to be small. Oh my goodness. If it's an investment and it's money going in, you want that to be big. So the first one is 8.03%. It's a pretty nice savings account. And the other one is 9.44. So we'd say situation 1 is the better option because that APY1 is greater than the APY for situation 2. Now, if this was loans, you'd want the reverse, right? So context matters on this. It's not always just whichever one is bigger is better. Oh, no, no, no. You got to use your common sense. If it's money coming in to you, you want the bigger interest rate. If it's money that you have to pay back, you want the smaller interest rate. So far, so good? Okay. We have one more financial product to talk about, and that is the annuity. So an annuity is just an account in which a sequence of payments is made. If those payments are the same amount, and made at the same time, i.e. like the end of every compounding period, we call this a regular annuity. I'm sorry, an ordinary annuity, excuse me. And that's all we're going to be dealing with in this class, are ordinary annuities. So there are two types of annuities. There's going to be like an investment annuity. And this is how most people save for retirement, is they put, like some amount of money from either every paycheck or every month into some kind of, like retirement savings account, whether that's an IRA or a 401k or some other financial product. But that's the idea. So the investment annuity formula is as follows. Where R is that regular monthly payment. I is just going to be R over 100K. Same R and K that we've used before. And then capital N is just little n times k, that's the same n and k that we've used before, and FV is the same FV. I'm not going to redefine these things. That if it's the same symbol over and over again, we're not going to keep restating them. So let's look at an example here. So here it says, at the end of each quarter, Sarah makes a $500 payment into an annuity account. If her investment earns 7.88% annual interest compounded quarterly, what will the value of Sarah's annuity be in 20 years? Again, I heard the word annuity like 5 times in there, so I'm pretty sure I know what formula I'm going to be using. Let's see, this is my R, or my big R, that's my little r, that's my N, that's my K, and that's everything we need, right? So if I start filling things in, so there's everything filled in. Now, getting this into my calculator can be kind of tricky. We got like a bunch of fractions inside of fractions and stuff. So I'm going to do this in 2 phases. I'm going to do the calculation for little I separately, and then I'm going to use that answer to do the calculation for future value second. So 7.88 over 100 times 4. So there's my value for little I. So my value for, or my future value then is going to be 500 times the fraction, 1 plus that answer to the 4 times 20 minus 1 over that answer. Everybody's okay? I press enter. We got $95,483.39. Not too shabby. I want to show you something though. What if our pal Sarah here, instead of doing this for 20 years, oops, can't do that yet. What if she got an earlier start and maybe was able to do this for, say, 50 years? What would we call Sarah? We'd call her a millionaire. That is what Sarah is. By saving $2,000 a year for 50 years with a moderate return, 7.88% is pretty, like that's a pretty average to, maybe to slightly above average return on investment if you're like conservatively investing in the stock market, diversified like in a mutual fund or an index fund or something. Totally realistic. $2,000 a year for her life. She is a millionaire at retirement and is sipping Mai Tais on the beach. The trick is that she has to start when she's young. The longer that money can sit in there collecting interest, that is the key to becoming a millionaire. Now, $2,000 a year, is a lot when you're 18, 19, 20, but isn't much when you're, 40, 50, 60, when you're really making, like at your highest income levels for your life. When I look around this room at all you like 16, 17, 18-year-olds, I see a lot of future millionaires here, or potential millionaires. You got to start now. If you don't make savings a habit, it's very easy to be like, I'll start that later. I got lots of time. This is the most valuable years right now. So start early, start often, save, 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 save. It gives you enormous flexibility later in life to where you're not having to like scramble in your pre-retirement years trying to catch up. Act now. Become a millionaire. Not that money's the only thing, but like, be smart. You want to take care of yourself. You don't want to have to worry about it when you're later. When you're an old timer, or just like, I want to relax rather than fret over how much money I'm spending on, garbage bags or something. The other way we can do an annuity could function is it also sounds a lot like a loan repayment, right? So like if you buy a car or you buy a house or you take out a loan for school, the bank gives you a bunch of money all up front and then you pay that back over a series of years with some interest accumulating. That sounds exactly like an annuity where you're making a regular payment. So here, PV would represent like the amount borrowed that you have to pay back. And then everything else is still the same. Like the little I is still R over 100K. Cap N is still little n times K. Yep. All those other letters are the same as what we've done before. I'm not going to rewrite them again. Everybody's okay with that? All right. So let's look at an example here. It says Maria buys a new car for $18,500. What are the monthly payments for a 4-year loan? So you see here that word loan. That's how I know I'm going to be doing the loan annuity. If she makes a $2,000 down payment and the annual interest rate is 2.9%. Woo, this is old. The interest rate right now is kind of tipping around 7. Hasn't been 2.9 for a while. So it makes everything so much more expensive. Anyway, so because it's a loan, I'm going to use my loan annuity formula. And let's see, we're asked, what are the monthly payments? That's looking for cap R. 4-year loan, so that's little n. Interest rate, that's R. What I haven't seen yet is and it's monthly, right? What I haven't seen yet is the PV. Now the amount borrowed is not $18,500 or $2,000. The car cost $18,500, but we're paying $2,000 right away. The present value, the amount that we have to borrow is the remaining $16,500. that. So there's that. Now to get r by itself, I would just divide both sides by that stuff attached to the r. But when I get down to do this in my calculator, I'm going to do this in like 3 stages. I'll kind of show you in a second. But this is what we're calculating. Yes. Oops. So I'm going to do this in my calculator in 3 stages. I'm going to do that little I calculation first. And then I'm going to do this thing that's multiplied by the r. I'm going to do that calculation next. And then I'll divide the 16.5 by that answer. So I'm going to do this in just 3 stages to keep everything manageable on my calculator, because your calculator only lets you do so many fractions inside of fractions and stuff at a time. And this just makes life just quite a bit neater if you just kind of piece it together a little bit. So that's what I'm going to do here. Oops, forgot my negative sign in there. That's important. Okay. So there's that. And then my last step then is to take my 16.5 and divide it by that answer. So my payment should be about $364.49. So the question here is really, how much did our pal Maria end up paying for this car, right? And then like what part of that was really just the interest on her loan. So like her total cost, well, she paid $364.49 every 12 months for 4 years, right? Sure. So let's do that real quick. So 1749.41, 17,495.41. And then our interest then was always going to be well, in this case would be like our total costs minus what we borrowed, right? So we ended up paying almost $1,000 for that loan in interest. What was that? 995. Forgot the decimal. 41. So instead of waiting for 4 years to buy our car, it cost us $1,000 to get it when we wanted. That's the advantage of being able to pay in cash and not have to take loans on things. But not most of us don't have like $18,000 laying around that they can just walk into a car dealership with a bag of money and hand it to them for a car. But if you can, it's a good deal. But you want to look at, in a lot of cases, it's still sometimes more advantageous to take the loan if the amount of money you can make on the investment, if that interest rate is going to be bigger than the interest rate on your loan, sometimes it still makes more sense to take the loan and save the 18.5 into an investment where you're making more money net on that. So it still can make sense to take the loan here. Content-wise, that wraps up section 15.5, and we'll wrap up chapter 15. But before we stop, I want to show you a really great tool on your calculator to do these financial type of questions. So if you are a junior and you have your calculator with you, I'd invite you to take it out. And I'm just going to show you a tool on your calculator you can use to do most of these finance type questions. It's a really helpful tool. It's a really useful tool, but it does take a little bit of practice to kind of get the hang of. It would be fine with me if you use this to do your homework, or if you use this on a test. This is totally fine to use to do these kind of financial questions. You would just need to write down your calculator inputs for me so I can have some partial credit I can give you. All right, so the place that we're going to press this purple apps button in the middle. You're going to look for the finance app. That's the only option I have on my calculator. And the one we want is the TVM solver. All right, so what I'm going to do is I'm going to just kind of work through some of these examples that we've done by hand using this TVM solver to do, so you can get a feel for how to use it. So the CAPN is that same as that we had in the annuity formula. It's the number of compounds per year times the number of years, so it's like the number of compounds. So in this example, it's going to be 1 times 3. I is your interest rate as a percentage. So in this problem, it was 6. My present value was $2,000. Now I'm going to write this down as negative $2,000 because the TVM solver is going to think about this like a flow. So if I'm thinking about this in the same way, that $2,000 is leaving my pocket and going into an investment. So it's like a negative value because it's leaving, that money is leaving me. We're not adding to that investment any, so the PV is 0. This is compounding annually. So we'll make the PY and CY both 1. And what we want is the future value. So we'll press alpha and then enter when our cursor is on the future value. And there it spits out the $2,382.03 that we got. That's nice, but that's not too bad. That wasn't rough to get into my calculator. I didn't have to do any algebra for that. But what if we were doing this problem where we had to solve for the N? So similar situation, right? So let's just update things here. So we have $1,000 invested. We have 6% annual interest compounded monthly. So my number of compounds per year is 12. So I'll make both of these PY and CY 12s. And our future value needs to be 4,000. We're not adding to this at all. And what we want is the time, so the CAPN. So there's that. But keep in mind, this isn't 277 years and 0.95. That's the number of compounds. So how often are we compounding? Monthly. So I'm going to take that 277.95 and divide it by 12 to get the number of years. Colby, what's up? I just copied I wrote down the number for N and divided it by 12 on the main screen of my calculator. God bless you. Right, I just press second and quit. and then wrote down 277.95 because I remembered it in my brain, and then divide by 12. So I didn't do anything inside of that TVM solver. I exited out of that and then just did it manually. Let's do this next one where we're asked to solve for the interest rate. So again, we're weekly for 10 years. So 52 times 10 for cap N. I is what we're going to be solving for. We put $600 in, so negative 600 as my PV. We're not adding to it at all. $1,500. Oops. 1,500. And this is happening weekly, so the PY and CY should both be 52. And then we'll move our cursor to the I and press alpha enter. And there's our 9.17. And this really was nice because that was like a lot of algebra to sift through to get to that number, right? We can do the annuity stuff on the TVM solver also. So if we go to the previous ones and we look at, let's start with the investment. Yes. So we have 20 years compounded quarterly. So our N is 20 times 4. Our interest rate was 7.88. We didn't start with anything in our savings account, so that would be 0. Our payment is going to be negative 500. Again, that 500, that 500 is like leaving our pocket and going into an account, so I'm going to make that negative. FV is what we're looking for, and then we're doing this quarterly, so my PY and CY are both 4. Move my cursor to future value, alpha enter, and there's my 95,000, etc. Now, if I had like screwed this up and said made that 500 instead, notice the only thing that's going to happen, I'm just going to get a negative number here. Big whoop, I know that this needs to be positive. It's not a big deal, but like that's why there's a negative sign in here, is that it's representing flow. If you have this wrong and it comes out as negative and then you write down the positive, that's fine. It's not a big deal to me. And then if I did the last one, again, the last one had some kind of a little bit sticky algebra to do. So it's a nice one to use here. So 4 years, compounded monthly, interest rate was 2.9. Gosh, that looks good. So our present value is the 16.5 that we borrowed. Notice I'm going to make that a positive number because that's money that's coming into my pocket. The payment is what we're going to be looking for. The future value is basically what I'm going to owe, which should be 0, right? We're paying this loan down to 0. And 12 payments and compounds per year. And then we'll move to the payment and do alpha enter. And there's my 364.49. It's negative because that's money that I'm going to be paying out, leaving me. But again, like the signage doesn't really matter to me. Like as long as you report your numbers as positives. The calculator needs the negative so it has like a direction to it. But so notice you can do like almost all of these financial problems using this TVM solver. You are free and encouraged to do that in the homework or in the on your test. That is totally fine. I would love for you to do that. 151. So the last of our problem set is 151 to 184. Feel free to use your TVM solver to do problems on that when appropriate. You don't have to report any work. You can just do it on your calculator and check to make sure your answer matches the odd answers in the answer key. That's a nice way to just practice, making sure you're confident using that because it's pretty helpful. It's super fast. I want you to use it. So this is me encouraging you to use it. And that wraps up chapter 15 for you guys. Next class, we'll do the review day. So you guys will make your half sheet and work on your review. If you want to start your half sheet early, you're welcome to do that. And then the following class will be our chapter 15 test. So I think that's like Monday and Wednesday next week, review day and then test day. And then after that, we'll start talking about sequences in series. That'll be the last topic for the year. And we'll just kind of play that by ear as far as whether we'll take a final test on that or if that'll just be part of the final exam. We'll just have to kind of wait and see how how much time we have. My suspicion is it'll just be part of the final exam, but we'll wait and see. Okie dokes. Okay.